morning, everyone. Great to see you all here. It's so nice and quiet in here. Wow. I don't even have to quiet down. That's wonderful. We have about 1 minute here before the official start time, but let's get some of the pleasantries out of the way here. There is a disclaimer. I'll bring this up. I don't really know what to say about the disclaimer. I think you should just read it, maybe. While that's on, I wanted to ask a quick question and get the interactive part of the session out of the way this morning. Who here has heard of passkeys? Okay, wow. Quite a few folks here. And then I promised the last question in this regard. Who here is planning on implementing passkeys within the next 12 months? Okay. Hoping by the end of the session to change a few minds, but okay, that's great, wonderful. All right, in the positive direction, let me kind of start with that. I hope to see more. With that out of the way, let's get started. So I'm Christian. I'm a product manager at Google. I've been with Google a little bit over 8 years. Before then, I was at a startup, and I did a lot of work in the FIDO space, even before I came to Google. So I've been part of the FIDO Alliance since 2013. At Google, I wear 3 hats. The first one is as co-chair of the FIDO2 Technical Working Group. That is where we are working on some of the standards that I'm going to be talking about today. And from the show of hands, it sounds like most of us are already familiar with the types of things that we're working on in the FIDO Alliance, but I'm hoping to take that one level deeper and also kind of show some of the products, which really is essentially what we've been building over these last couple of years, some of the products that came because of those standards. So on the standards body there in FIDO2 Technical Working Group, and then I'm also the product lead for FIDO2 or passkey implementation on our platforms at Google. So Google has 2 major platforms. We have Chrome, we have Android, so both platforms used by a large number of users out there in the world. The way that the implementation kind of works is we started out by deciding in the standards body what it is that we wanted to build. The very next step was to then take that technology and build it into platforms so that folks like you all here, as well as me, which I'll talk about in a second here, as the representative for Google.com account security here this morning, so that I can also start using passkeys. Because if you think about this, we started on just this journey 10 years ago at Google because this is where we wanted to get to. We wanted to implement passkey support for Google accounts. That is our goal. A great side benefit is also having passkeys available for the rest of the world, because this technology won't succeed if it's only a Google thing. We want the world to move away from passwords to passkeys. And I think throughout the presentation here this morning, I hope to convince the folks here in this room that we're finally there. We are literally at the point where mass transitioning away from passwords to passkeys can start to happen. And at the same time, as you'll see throughout the presentation here, that also means we can start to navigate away from legacy, call it band-aids, that we had over passwords for years, right? Things like 2FA, multi-factor authentication. Those things are band-aids that we put on top of passwords because they didn't live up to the expectation that we had for them. Passkeys is kind of a clean slate. At the same time, it's a migration away from all the UX hassles regarding passwords, but it's also a much more secure and kind of like a purpose-built framework from the ground up. Before I move on to the next slide, I'll say one more thing. For 30, 35 years, right, if you want to implement a website or a service on the internet, you don't think about transport layer encryption, right? It's built right into the platforms, right? SSL, TLS, really. It's right there. No one, there's not even a conversation about it. We use TLS and that's the end of the story. We don't have that for authentication on the web today. Everyone is building their own custom authentication solutions. Sometimes it's just passwords. Most of the time now it's password with some additional layers on top. The goal with passkeys is to give the world a primitive, like we have in TLS, for authentication on the web. And when I say on the web, I really mean on apps as well, of course, right? Both kind of here work together in unison, as we'll see a little bit later. But that's the goal of passkeys, a authentication primitive for the web. So the agenda, we'll do a quick overview. I think folks here are mostly familiar with it. I want to review some use cases and critical user journeys. Before I do code samples, depending on if I can make my rig work here, I want to do a live demo, which is always kind of fun, just to show you how this stuff works in principle. I have the screenshots, of course, on the slides as well, but it's much more fun to see this working in kind of like a real live implementation. So I want to show that if everything here works out this morning. Briefly jump into some code samples. I'm not going to bore folks by stepping through code line by line, but I want to show how easy some of the experiences that we'll look at is to achieve. on your websites or in your apps. We'll focus more on the website, but it's very similar if you want to do an implementation in an application. And then lastly, kind of that was the title of the slide, so I have to end with that. What's good, what's still bad, and what's ugly in passkeys, and we'll talk a little bit about that as well towards the end of the deck here. So why don't we jump straight in? So passkeys. Passkeys is a public-private key credential. Public key is what's sent to the service to identify the user, and the private key is the portion that remains with the user on their personal device. Unlike with shared or symmetric shared secret systems, passwords, OTPs, these kind of technology where the service provider and the user both have a secret to keep, here, what the service provider needs to keep is a public key, which means, heaven forbid, were there to be a data breach on the server side, nothing happens, right? Yes, these public keys leaked out, but those public keys can't be used to authenticate the user. The private key that the user always keeps in their possession is what's being used to essentially give a proof of possession of that material without ever revealing the actual private key to the service. Like, so this is standard, like 101 crypto, digital signature, essentially signing a hash that comes from the server side, signing it with your private key, sending it back to the server, and the server can validate it without ever revealing that very important like private key. That is kind of like one of the tenets of FIDO and why we think FIDO and passkeys, and for folks here, when I talk about FIDO and passkey interchangeably, passkey is essentially a type of FIDO credential, and I'll dig into that a little bit more in a couple of minutes here as well. So public-private key cryptography is what everything here is built on. The second thing I quickly want to mention from a security perspective is passkeys, as with any kind of FIDO credential, has been designed from the ground up to be resistant to phishing. And I think that's the number one reason why we started down this journey about a decade ago. Passwords and essentially all other sorts of authentication on the web today are phishable to some extent. Whether you're using TOTP, whether you're using SMS OTP, whether you're using push-based authentication in an app, it is all phishable, right? The only thing that's not phishable perhaps is like smart cards and PKI, and who deploys that at scale? So the thinking was, can we get those security, essentially the security benefits of a solution like PKI-based smart cards and all this other cool stuff, PERV, whatever we see in government, how do we actually take that and deploy it en masse for consumers? And passkey really is the result. So first, public-private key, so no risk of breach, or at least data loss when there's a breach. The second thing is no password reuse, of course, because all these credentials are unique. It's system-generated. Third thing is these credentials are all phishing-resistant, strongly phishing-resistant. So one of the biggest issues, if you look at the Verizon data breach report, every single year, phishing ranks right up at the top. So we're hoping with passkeys, we get away from that. Now let's move to the stuff that the consumers get excited about, and that's convenience, right? Today, passwords, hard to manage. Every single time you interact with a new website, you need to make a new one. You need to manage these. Passkeys are inherently managed by the system that you're on. So essentially, if you're on Android, your Google Password Manager or whatever other password manager you choose to use on that system, you pick one that supports passkeys, will manage your passkeys for you. Your passkeys will be stored on that device, and optionally, those passkeys, depending on the type of provider you use, will also be safely backed up and synchronized. So if you ever move to a new device or you change to another device, your passkeys will still be available. Now, how do we use a passkey? A passkey gets used on the device with a very familiar device unlock mechanism. So for example, if you want to use a passkey on your phone to log into, I don't know, Facebook tomorrow, the way that you would use the passkey would be to touch your fingerprint on your phone or show your face to your biometric face unlock, or do whatever your unlock pattern and password mechanism on your phone is. So the way to use passkeys is very, very familiar. Just do the device unlock mechanism that you normally do, and that is how the key then gets unlocked for use to the service. Now again, I know all of this is very high level. We'll jump into some screenshots and demos here in a second to make this much, much more real. And apologies for the folks who've already seen all this stuff, but I think there's probably enough changes that happened here over the last couple of months that it's probably useful to go over some of those screenshots and flows again. So earlier I said passkeys is just a type of FIDO credential. Now, for folks who've been following FIDO for a while, we've been talking about FIDO and FIDO credentials for a long time. FIDO credential, public-private key credential, that is phishing resistant, all that stuff was great. The problem with traditional FIDO credentials used to be that these credentials were bound to a single device. When you make a FIDO credential, and you make it on a phone or on a PC, or even on a physical security key, for folks who've seen those little USB dongles, if you make that key there, that key lives on that dongle or on that device only. Now that's fantastic, and it sets a really high security bar, but the moment the user moves to a new device or get a new device, the key is gone, right? And they have to start from scratch again. And what does starting from scratch in this paradigm mean? You fall back to usernames and passwords, and that's what we don't want. We want, once a user steps into the passkey world, into the FIDO world, to remain there forever, and really never have to fall back to other types of authentication. We're all very familiar with using biometrics on our phones to unlock our favorite banking app, right? Great, you open your banking app, you touch your fingerprint, and you're in. What happens when you buy a new phone? You're right back to signing in with a username and a password and an SMS OTP again. And then you get back your biometric capability. That's what we don't want for passkeys. Once you're in biometric world or in passkey world, whether you move to a new device or change to another device, you're always going to be in passkey world. You never have to fall back to those old types of less secure fallbacks and less user-friendly fallbacks. So we built syncing into the standard. Passkeys synchronize, as I said earlier. The goal of a passkey is to remain resilient. So once you make a passkey on an Android device or on an Apple device, MacBook, iPhone, iPad, doesn't matter. Once you make those are backed up. And if you get a new device, as long as you can authenticate back into wherever these keys are stored, and with Apple it's in the case of iCloud Keychain, with Google it's in the Google Password Manager, as long as you can authenticate back there, you get your passkeys back, and you can start just continue where you left off. So that's number one. The synchronization and backup aspect of passkeys make them resilient. Much like a password manager, right? What would be the goal of a password manager that only keeps your passwords on one machine? And if you change machines, all your passwords are gone. Doesn't make sense. So the same here with passkeys. Once you have your passkeys in a specific device, it outlives that device, essentially. The second thing that is a little bit more novel and works a little bit differently than a password manager is cross-device use. So today, if I have my passwords on my Android phone, and they're stored in a password manager and safe there. If I ever want to log into another device, say a laptop or a desktop, what do? Well, I open my password manager, I look at the password string, and I type it from this little screen there onto the keyboard of my other device, and that's how I log in. Not very secure, right? That's the point at which the user can get phished, the user experience isn't great. So we decided we wanted to address that. Because passkeys aren't credentials with like a single string, it's like essentially a cryptographic key. There is no way that the user can retype the cryptographic key from the device, the phone into the laptop anyway. So we had to solve that problem. And we solved that problem with a standardized Bluetooth protocol, which it uses Bluetooth under the hood, but users don't need to be aware of it. There's no pairing. There's nothing that you need to do. All of the major operating systems and platforms agreed on this protocol, so this protocol is implemented and working in Windows, Apple devices, Android devices, Chrome OS devices. So you can use your phone that has a passkey to log onto a service on your laptop that does not have the passkey, and magically that passkey will be, think about it like, used across the air gap from the phone to the laptop using this proximity Bluetooth protocol. Now, first thing that may come about, isn't Bluetooth insecure? Well, the first thing we're doing here is we're reducing the attack surface from someone in physical Bluetooth range, right? With passwords, anyone, anywhere on the globe, if they have your password in a password dump, they can try and log in. Here we're saying, unless someone is in physical proximity of your phone that has your passkeys, there's no chance that they can log in using your passkey. And even then, there's additional safeguards on top of that. The passkey can't just get used. You'll get a prompt on the phone that says someone is attempting to use this particular passkey on your phone to log in somewhere, and there's even a pairing step, and I'll talk about that in a second. Not to be confused with Bluetooth pairing. That's not really what we're using here. I kind of like to talk about it more thinking of linking. There is a mechanism where you need to say, this phone and this laptop should now communicate to one another using this new protocol that we're using in FIDO, and when you establish that link, then you can use passkeys on one device to sign you in somewhere else. What normally gets a little confused is, once I've done all of that, I can now establish a new passkey relationship on whatever new device I'm signing in on, so that in the future, I don't need my phone every time I want to sign into a service. If I use my phone to sign into my bank on my Windows 10 machine, my Windows 10 machine now also becomes a passkey, right? There's a passkey on my Windows 10 machine for my bank, so next time I come back on that machine, no phone needed. I just use the biometric capabilities built into my Windows machine to allow login, and then I continue where I left off. All of this will become a little bit more clear when I show some of the screenshots and the demos a little bit later on in the deck. Last thing I want to quickly mention on this slide, discoverable. One of the key problems we've had with passkeys and when it came to implementation is, for a whole long time, users will live in two worlds. They will have passwords, and sometimes they'll have passkeys. How do users know whether they already signed up for a passkey on a specific site? We interact with so many different services every day, we don't really want to recreate this NASCAR problem of like, did I sign in with Google or sign in with Apple or sign in with Facebook, or do I have a username and a password? not great, right? So what we want to do here is we wanted to have a mechanism where the system can intervene. And if you happen to have a more secure credential like a passkey available, the system would immediately tell you and say, hey, don't type. You have a passkey. So we've integrated passkeys into the autofill systems on all the major browsers. So if you're in Safari or if you're in Chrome, if you happen to have a passkey available on that system, the OS will intervene and tell you before you even start typing, hey, you have a passkey here, just click on this, touch your fingerprint, and you'll be signed in. Show a little bit of that also later. The other thing that I haven't really mentioned is, yes, passkeys is a passwordless technology, but it's also a username-less technology. There's no typing of usernames any longer. All of your credentials get serviced up to you, and you then have the option to pick the one you want to use. You can use passkeys and layer them on in certain ways where usernames are still supported, but for most implementations, most new kind of like blue sky implementations, we think you should just jump in immediately, get rid of both the username and the password, and just allow the passkey system to kind of take care of that for you. Again, we'll talk about that a little bit more. Passkey availability, where can this get used, right? Today, it is pretty much everywhere. However, this slide is a little confusing. There's like lots of different things and edge cases and other stuff on here, but the more important thing is, in every single column, there's at least some green, which basically means all major platforms supports passkeys to some extent or another. I like to rather show this slide, right? Apple, Google, Microsoft. It's supported across the major platforms today. So if your users are Windows 10 and above, Android, like Apple, on those systems, users are mostly running the latest OS versions anyway. On those devices, users should have the ability to use and make passkeys today. So it is no longer a case of, hey, we need to wait for another 6 or 9 or 12 months until users have this technology in their hands. Most of your users today already have the tech on their systems to be able to use passkeys. Now it's just a question of really starting the rollout. So how does passkeys work? As I said earlier, passkeys enable you to sign into a site using the familiar biometric capabilities of your phone. So today, if I want to sign in somewhere, instead of typing a username and a password, I'll have the browser intervene and say, hey, you have a passkey for Bob. Do you want to sign in with Bob? Click that, touch your fingerprint, and you're going to be signed in. And because the passkey both essentially tell the remote service about the private key that it has without ever revealing the private key, as we said earlier, right? It's kind of like a cryptographic like hash that gets signed and sent back, so the remote server can verify you have access to the private key without ever learning it. So you get that, but you also get the knowledge that the user was actually present at the keyboard or at the device, because remember, we had to unlock the key with the biometric or with the screen lock. So you get both factors, both a possession factor and a biometric or knowledge factor at the same time whenever FIDO authentication happens. So that allows us to start moving away from multi-factor, traditional discrete multi-factor, to using FIDO or passkeys, which gives you two factors in one. It both gives you possession and either knowledge or who I am, like kind of biometric challenge at the same time, which allows us to meet certain regulatory criteria which is being set around payments and other stuff where multi-factor authentication is still kind of like enshrined in law, so to say. Talk a little bit more about regulation also in the deck here, because regulation, of course, needs to still catch up here. We don't really have passkeys being called out directly there yet. That's one of the things that we're working hard on, but we think we can thread the needle there. Because passkeys does do two things at the same time, it is both a possession and a biometric, or a possession and a knowledge factor. We think it meets the criteria or the spirit of most of the regulation that we see today. So as I said, passkeys are meant to replace both the traditional multi-factor and the password. I'm not going to go into this too much, so you don't need to maintain separate systems. Hopefully the user can do one single thing. Cheaper for the organization because you don't have to maintain these additional systems, but also much easier for the user because it's a single thing you have to do, which also helps with the funnel, less drop-off, and depending on the business you're in, less drop-off normally means more money. So I want to talk a little bit about the use case overview now. And I was kind of thinking how to do it. Let's first look at the slides, and then we look at the demo. Let's do it that way. I think that way if the demo doesn't work, it's not such a big disappointment. I hope it will, though. But let's talk a little bit about Eliza. So let's check in on some of Eliza's experiences with passkeys. So on day one, Eliza wants to sign into her bank's website. She banks with a bank called TriBank. And today, Eliza knows all about usernames and passwords. That's how she uses to log into her bank. That's what she uses. So she types her username and she types her password. When she does that, she gets logged in, and the bank app, essentially, is smart enough to realize that ELIZA is on a platform that fully supports passkeys. There are silent APIs, which I'll talk about later, which anyone on the web can call, and the platform will return to you whether or not passkeys are supported here. If you get back a true, like yes, passkeys are supported here, you can serve the user some kind of an upsell. Now, I think that upsell is a little bit small there, but it says something like, hey, passkeys are here, they're easier to use. Again, from our own user experience research that we've done, leading with the easier to use is definitely the thing to do. So leading with passkeys are easier to use and more secure. Do you want a passkey, right? That's kind of like the pitch that you make to the user at this point. And this, of course, is completely customizable by the website. That's a dialog box that gets rendered by the site. So hopefully at that point, the user says, sure, yeah, give this to me. Some websites we've seen also leans a little bit more heavily on the biometric aspects and say, do you just want to sign in with biometrics here next time? That messaging also resonates, so the user says, yes, that's exactly what I want. And at that point in time, Platform OS, and we'll talk about the Platform OS in a second, now takes over. And it now depends on which platform the user is on. If the user is on a Chromebook, it'll look something like this. If the user is on a Windows machine, it'll look completely different. If the user is on Mac, even more different. And Android, yet another way. And that sometimes is a little bit hard. And that's kind of like also a little bit of a sneak preview towards the end of the deck where we talk a little bit about the good, bad, and the ugly. Every platform still has their own UI. Of course, that's how it's going to be because every platform is different in how it communicates to the user the process of making and using passkeys. Now, we are on a path to convergence. That's why we have the FIDO Alliance, where all of us come together in talking about our own UI and taking, I guess, hints and recommendations from others. But it's important to note that you only have so much control over this process, right? You can pitch the user passkeys, but then you essentially throw the user over the wall into the system UI, which then takes care of the rest of the process. Now, again, here, it talks to the user a little bit about passkeys again. It's now the system taking over. Tells the user about the passkey that they are going to create. Now, remember, a password, that's just a string. A passkey is not just a string. A passkey, think of it as like a credential. Think of it like almost like a driver's license, right? It has a name. It has like some secret component that makes it authentic. It could even have a little icon. In this case, it doesn't. Like a passkey is a little credential that gets showed to the user, and it says, you're about to create this credential. All of the information that's displayed there is passed in by your website. You get to pick what the user sees. You get to pick what the user's username, if you have a concept of that, has, or if you have a concept of that, you'll pass that in. And in the future, like you can even pass in a little icon or whatever. We're just kind of like working on that in the spec right now. But you can pass in at least the display name and the username component for the user to see. So the user sees, I'm about to create a credential. Then there's a verification step, and the verification step would usually be biometric-based if the system has biometrics. If the system does not have biometrics, we try and fall back to something similar. That might be like an unlock PIN code. If you think Windows Hello, Windows Hello has the option to have biometrics or a couple-digit PIN code. That couple-digit PIN code is what the user can use in lieu of the biometrics if they so wish. Same on a phone, right? We all have phones. Most of our phones have biometrics, but we all know we can unlock our phone a different way as well. And mostly at startup, we do unlock our phone a different way. PIN code, pattern, password. So that's the same here with FIDO. Like you always have that alternative. Now, the first thing I think everyone here gets that, but the PIN code, the 4-digit PIN code is not more insecure than your password, remember? Because a password can be used everywhere in the world. That PIN code only makes sense and is only active on the user's actual device. So anyone who knows your PIN code also physically needs to have your phone in their hand, which is completely different from the way that passwords used to work, right? A password by itself gets a user in. Here, the PIN code is a layer on top of physical possession, which is really what FIDO and passkeys is all about. It's bringing down the attacks from anyone in the world to someone with physical possession over your hardware. So anyway, with that, user sees a prompt, user clicks, and the user is signed in, as per normal, right? So now they're kind of like signed in, and they can go on their merry way. I want to quickly call out, this looks slightly different on different browsers. On the left there is what it looks like on Windows. That is with Windows Hello. So that is the face camera thing that pops up and says, hey, show us your face. On Safari, with a fingerprint sensor, again, it looks slightly different. We're trying to ensure that our messaging to the user in all of these cases are the same, so that you, from a website perspective, don't have to prime the user individually based on the OS that they're on. We really don't want that, right? I don't want if statements or case statements on the relying party side going like, oh, if this user is on Windows, we need to talk to him a certain way. Let's just all talk to the user about passkeys, and then we use the system to essentially take that one step further and get the user to complete the process, which here is the process of creating a new passkey for that particular user. And again, if folks have comments, this is early days, right? If there's comments here, we can still change things. And I think we are going to change things and like shave down or sand down rough edges here over the next couple of months, but we really can't do that unless we have adoption. So that's kind of like part of my plea to the group here this morning. We really need to get this stuff in front of regular users. And Google will put our money where our mouth is soon, where we want to start getting more users in front of this technology. And I think, I would love folks in this room to do the same thing. And most importantly, give us feedback, because I think this will succeed if we are able to, as an industry, move users to this new technology. So next year when we stand here, even on the bus coming in, if we ask folks about passkeys, they're yes, of course, whatever. The passwords are per se. We know passkeys is the way forward. That's certainly not the environment that we're in right now. Super happy to hear that we have so many folks here that understands and knows about passkeys, but I think we need to get to the next level now and get it outside of this room as well. And this UI, I think, is the crux. We need to ensure that this works reliably and that users understand that bridging that gap from the UI of the service into the system UI. And on phones, as I said, it looks kind of roughly similar. Android on the left, iPhone on the right. Again, very similar messaging, talking about passkeys all the way through, and trying to bridge that gap for the user. So how do we sign in? Sign in is kind of just as easy, right? User clicks into the username field. This time the browser says, hold on a minute, you don't have to type here. We already have a passkey for you. It looks very much like a saved password, right? You see right at the top there's that little, I know it's so small, right? But it's a little passkey icon that says, hey, you have an Eliza Beckett account here. Once the user clicks on that Eliza Beckett, immediately the system UI kicks in again and says, hey, just touch your fingerprint and you're signed in. And that icon was dynamically rendered because the user happened to have a passkey on that system at that point in time. Now, if they didn't have a passkey, don't think that's in my slides here, but we'll share it in the demo. If they didn't have a passkey, suddenly another item became available in that dropdown, which again, I don't know if folks can see it. The last one there, which is like use a passkey from another device. Now remember I spoke about the Bluetooth protocol a little bit earlier, where you can use a passkey on a phone when you're on your laptop. That's what will get invoked when a user clicks that button, and we'll see that in a couple of seconds here. So again, even the sign-in looks slightly different, but this is kind of like a parallel to the creation step, right? So the different OSs does very, very similar things with create and sign-in. Windows on the left, Safari here on the right, and then we have our same two phones, Android and iOS, during the sign-in step over here. Passkeys, right? So you have one password for an account, typically, not really much more than that. Passkeys are a little different, because I might have a passkey for my TriBank account on my iPhone. Now that passkey on my iPhone will automatically get synchronized to my iCloud account, which means it's also on my MacBook and it's also on my iPad. That's the same passkey, lives everywhere around there. However, if I want to sign into my Windows desktop, what I'm gonna have to do is I'm gonna try and sign in. I will use the Bluetooth cross-device protocol to use the passkey on my iPhone to authenticate the sign-in on my Windows machine. Remember, the passkey never actually moves. It's just a proof of the passkey that moves via Windows to the remote server. Now I'm signed in. However, I have a Windows Hello-enabled laptop, which can also do passkeys. So the system, which we'll see in my demo, will then prompt the user and say, hey, do you want another passkey on your Windows device too? Now I have two passkeys. One lives in iCloud, one lives on Windows. And if I sign in on another Windows device, now I have three passkeys. One on Windows here, one on Windows there, because Windows doesn't sync passkeys yet, and then another set of passkeys that's living inside of iCloud. So these things can get a little confusing to the user, so we think there's a important use case here for allowing users to manage, right? Think of this the same as session management, right? If you allow, let's say Gmail, for example, today. If you sign into Gmail, you can go to session management and you can see where all am I signed into my Google account today, right? There's management for that. We think there is a parallel here for passkeys where you need to allow users to at least audit, hey, I have these three passkeys. Maybe I signed in on my girlfriend's machine like a month ago and I saved the passkey there and then we broke up and now I don't want that machine to sign into my banking account anymore. So I need to have a way to go and audit and revoke. I haven't really seen good examples of passkey management yet out in the field. We have seen some implementations of passkeys. This one is still one that I think as an industry we can do a little bit better. And I'm hoping that over the course here of the next couple of months, we will start seeing more and more of these examples that can be used as reference examples. So next year when I stand here, I can point to one and say, that's actually a fantastic example of how management should work. But as I'm saying, like, a lot of this stuff is still early days. This is part of kind of like the ugly, right? We haven't gotten this figured out quite yet as an industry. The technology and the tools and the protocols are there, but this is now kind of like the type of stuff that we have to think about a little bit more in concert with our, UXR and other counterparts, other organizations. Now, before we talk some code, see if this demo works. So I'm going to bring up Chrome. Now I have a new Chrome available. Man, should I do this? Let's update my Chrome. I don't know. It's kind of like, if you don't upgrade Chrome, then it gets angry. If you do upgrade it, the whole demo might just get messed up, but, All right, so I'm still here. That looks good. The next thing that I need to do, which has nothing to do with my demo, but I do want to show you my Android device on this screen, because otherwise it's only me that can see it and it gets very boring. So I've got my Android phone here, which it should be my real phone, right? So you can see the phone here too. So what I'm going to do is I'm going to start out by going to Chrome on my Android phone, and I'm going to sign into this TriBank that I had the screenshots about earlier, right? So first thing I do is I sign in using my password, because Eliza is still a password user today, right? It's day 0. Doesn't know anything about passkeys. So Eliza signs in with her username, Eliza signs in with her password, and we hit sign in. And then let's see what happens. So immediately, well, on my phone at least, immediately it pops up and it says, use a passkey for stronger security. So we're seeing the value proposition here pop up on my phone. Unfortunately, it seems a little slow to refresh, so I'll try this one time. If it doesn't, I'll just talk you through it and show you the one on the web a little bit earlier. Sometimes the screen sharing can be a little bit flaky here in the big holes. But I'll try this one more time, right? So you can see that use a passkey for stronger security. I'm going to say create. I'm going to say, yep, give me a passkey. There's a glyph about the passkey being created. I'm going to touch my fingerprint, and I'm going to create the passkey, right? So I've got a passkey. I'll go quick because I don't want it to break again. Next time when I come back to this page, when I click into account name, I get a pop-up that says, hey, hold on, don't type. You have a passkey. All I do is I click on the passkey, I touch my fingerprint, and I'm immediately signed in. You can also do this in apps. I have a passkey on the web, but a passkey on the web and in an app works exactly the same. So tomorrow, Eliza downloads the TriBank app from the App Store, and she goes to TriBank here, and she clicks into the app. And because I have a passkey available, it just pops up and says, hey, you've got a passkey here. Don't type. And remember, that's the passkey I just made on the web. So there's seamless interoperability between app and web across Android. So I say, cool, let's use it. Touch my fingerprint again. And once I do that, I should be fully signed in to TriBank on the app as well. OK, this all still kind of works pretty standard. However, what I also want to show is, what if this user wants to sign in on their Mac, where they don't have a passkey? So I click into enter account name. There's no passkey, but there's this option, use a passkey on a different device. So I say, that's cool, let's do it. Ignore that. I click on that one. Do a QR code. That's because I updated Chrome. So open my camera on my phone. And there's my camera on my phone. I will scan the QR code. It should say use a passkey down here. I click it. There's a Bluetooth connection between my laptop and my phone happening right now. The passkey I created a couple of seconds ago on the phone gets displayed to me. I say, yeah, that's the one I want to use. I touch my fingerprint. And once I do that, the laptop should be logged in. Now, the laptop doesn't have a passkey yet, but I can create one because, again, there is passkey technology available in the laptop. So I'll show actually with my camera here. Is that still working? Yeah. If I say create a passkey, it again tells me about the passkey I'm about to create. I touch my fingerprint on the fingerprint sensor of my laptop, and now it makes me a passkey. So next time when I log out of TriBank here on my Mac and I want to log back in, I don't have to do phone stuff again. I simply click into the account name field. There's the passkey I just created. I click it, I touch my fingerprint, and I'm going to be signed in. And that single step encompasses 2 factors of authentication, both possession of key material and the user was in front of the device at that point in time. Okay, I'm glad that demo actually worked. All right. So let's briefly look at some code samples. I want to make sure that we have about 5 or so minutes towards the end here if folks have questions. So I'll go through this rather quickly. My goal isn't for this to be a code lab, so I'll go through this, like I said, rather quickly. Remember we saw the user see a create step, but that's always the first step. You need the user to make a passkey. Just like you need the user to make a password, like in password managers, that's a step now. It generates you a password. Passkey, you need to generate or make a passkey for a specific service. Again, if this wasn't clear originally, passkeys are unique. For every single user account and every single service, passkeys are unique per account, per service. So if you have 5 accounts with Google, those are all separate passkeys. They can never be shared, they can never be reused like what we see with passwords all the time. So to create a passkey, pretty simple here. I know that's kind of like maybe not the best font choice here, but it's fairly easy. You have this concept of public key credential creation options that you pass in. You call this function called navigator.credentials.create, and you just populate it with a bunch of parameters. Most of these parameters are standard. You don't even have to think about it. You get to populate it with the name of your service, the URL that you're binding these passkeys to, because again, all passkeys are bound to what we call web origins. That's how we get the non-phishing capabilities, right? If you bound the passkey to Microsoft.com, Microsoft with a 0 instead of the O will not get to use that passkey. It's as simple as that. The system will just refuse, right? But today, because users are being asked to be essentially that arbiter of, am I on the right website? Am I on the wrong website? Do I, can I read puny code? I don't know. All these huge things that we have to think about when getting phished, all of that is taken care of by the system with passkeys. Because if the website you created the passkey on is not exactly the same website that's asking for the passkey, the system will simply refuse to hand that passkey option to the user. There's no way, like with a password manager, you can go and copy and paste the password accidentally into a field, because these concepts just don't exist in passkey land. So anyway, very, very easy. Pass in a couple of parameters, and you get that dialog box that the system creates for you that says, hey, this user is trying to create a passkey. So very straightforward. The next thing you want to do is you want to use a passkey, right? So you want to have your login pages bring up this special little modal window here that says, if there's a passkey, show it. If there's not a passkey, tell the user about using passkeys from different devices. And again, you can do that with this last call down here. What we have right up at the top here is the little snippet of code that you can call to detect whether passkeys are even available on the platform. It's a completely silent call. It doesn't cause any UI for the user to appear. You can start calling that today and silently logging it to see if you actually have enough users with passkey-capable devices, and I think you'll be surprised at the numbers of how many of your users interacting with your services today would already have technologies and devices that's capable of doing everything that we spoke about here today. So again, there's a couple of options you have to pass in, but pretty straightforward, pretty much just like the challenge, because everything here is cryptographic-based, right? So you always want to generate some unique challenge that'll then get signed on the client side, and then that response is sent back to the server, and you can validate it using the public key you've got. So again, not to dwell on this too much, but I wanted to show it's not like pages of code. It really is a couple of lines, which is all that you need on the client side. Now, of course, this isn't the whole story. On the server side, you need something that can parse these signatures and like store this data. That's where the FIDO server program comes in. This is an open standard, right? Anyone can implement all of that logic themselves. You can pick from a bunch of open source servers on the web, or you can go commercial. So there's a whole range of options available for implementing this on the server side, but that is where the probably couple of tens of thousands of lines of code comes in versus the couple of lines which you need on the client side to render this, because here the platform's already taking care of most of the heavy lifting. We render all that UI for you. You just have to tell us where to put it, and then we'll take care of that for you. So in conclusion here, guess I have to work this in somehow. The good, the bad, and the ugly, right? So good, I think passkeys are here. They're available. They are a significant UX improvement over passwords, and they provide for much better security guarantees. In particular, the whole password washing and the remote site data breaches and the strong phishing resistance. I mean, all this stuff that we keep hearing about daily, when everyone's on passkeys, those things just go away. They just don't exist anymore, right? The bad? It might take some time for regulation to catch up so that we can use these everywhere we want to, right? As I said, I'm not aware yet of the word passkeys making its way into any regulation today. So they are a drop-in replacement for passwords. They definitely give you a better security guarantee than a password. What we would like is to replace passwords plus whatever MFA and other layering has been done in the past. That might need regulation to catch up in certain industries. So we're working very hard as FIDO Alliance on trying to make that happen and convincing regulators that passkeys are actually not only a safer alternative to passwords, but a safer alternative to passwords plus whatever other mitigations and band-aids we had to adopt over time. Last thing, the ugly. Passkeys are new. It'll take some time for users to become accustomed, and at the same time, all these different system UIs, right? Users being bound to Chrome OS and to Windows and to certain Safari UIs and Android UIs. If we don't have a nice cohesive message there, users can very easily become kind of distracted and distraught in navigating this process. It is early stages. There are rough edges to sand down. However, the good news is I do think what we have and what we've put out there over the last year to really get to this point is ready for initial adoption by users, and without that adoption, we're not going to get the feedback that we need in order to sand this down further. So I guess the ugly is, like, this is still something that we need to work on a little bit as an industry together, but we can take the first step. And I think, we want to put, like I said earlier, our money where our mouth is too, and start to put these things in front of users in more concerted ways. The last thing I'll say, I just briefly touched on that earlier. Understanding when passkeys are synced and not is kind of tricky, right? You have, like, on iCloud, passkeys are synced. On Windows today, you have different passkeys. On Android, your passkeys do sync from Android to Android, but it doesn't sync, for example, if you're on Android and then you go to Chrome on Windows, those passkeys don't sync. Passkeys sync within their ecosystem. Apple is an ecosystem. That's where they sync. On Android, we sync passkeys Android to Android. We can have a whole long talk about why that is the case, but from a security guarantees perspective, that was something that was easier for us to bite off. However, I will say on Apple, for example, the plan is that whether you're running Safari browser on Mac, or whether you're running the Chrome browser on Mac, or whether you're running any other browser on Mac, you should be drawing from the same Apple iCloud key store. Today, the inverse is true. If you have Safari running on Mac and you have Chrome running on Mac, your password managers are totally different. So we want consistency, but for passkeys, we have platform-level consistency. Same on Android. On Android, if you run Edge or Chrome, excuse me, all your passkeys are pulled from the Android Google Password Manager store rather than Edge has their own and Chrome has their own. There are certain security guarantees that we can get when we defer the management of passkeys down to the OS rather than having the app level, the programs there manage these passkeys ourselves. So that is something that users will need to understand as time goes on. Why is my passkeys available here? Why not there? I think the OS and the platforms play an important role in navigating that for the user. If there is no passkey, bring up the QR code. Tell the user to scan the code. Oh, we didn't really talk about the QR code so much. So the QR code is not meant to be a way to transfer passkeys from one place to another. It's a way to disambiguate systems. Like you can see here, there's 2 laptops and 2 phones in front of me here. The Bluetooth protocol is great, but the Bluetooth protocol don't know which device to connect to which phone. So that QR code we looked at earlier is a way to tell the phone and this laptop to temporarily link to one another over Bluetooth so data can be transferred. So this QR code thing, how well does users do with QR codes? After the pandemic, more users are used to seeing QR codes and scanning them with their cameras. But all these things are stuff that'll have to be tested as we're moving forward. So I think from a security perspective, we're there, we're happy. UX and UXR is what will, I think, that'll be the next phase that will need to be ushered in to figure out what else do we need to focus on, and as an industry, which changes should we be making to make this even easier for users. I want to end with this and say, like, we're all in on passkeys, right? We think passkeys is the thing that'll finally replace passwords, and a lot of effort and a lot of investment has happened here over the last 10 years. We'll continue to invest in this space, and we would love for everyone here to kind of like join us on that journey, and be one of the early adopters and not one of the laggards. I guess it's kind of like my last pitch here. So next week, we always have to end off with these slides at Gartner and at RSA now. Next week, you should identify core applications in your organization which could benefit from passkey deployment. Figure out, are there any apps today that you can start dipping a toe in the water on? The next thing you have to do is figure out what to do with the FIDO server, right? The client-side stuff is fairly easy. On the server side, you do need a little bit of technology. So either are you going to build, are you going to buy, are you going to go open source? There's many options there to investigate. And then lastly, hopefully within 6 months, you can actually have a passkey implementation underway to start to show ROI to your stakeholders inside the organization, and hopefully help drive fraud and cost down and just get a better experience for your users. With that, thank you. We have about 5 minutes in case everyone is interested in questions. Either feel free to run up to the mic or just come and grab me up front here. I'll hang around for a couple more minutes. Thank you.
Yes, so I have a question because we are more familiar with the standalone hardware token, the FIDO2 key, right? So is this software version is going to replace that, or how do you think?
That's an excellent question. This version lives alongside that. So everything that I've shown you here also works for physical hardware keys. So if the website says, make me a passkey, by default, the website will try and make it on the platform. But if the user picks, they can say, I don't want it on my platform, rather make it on my removable FIDO2 key. And everything here should still work from the website's perspective. So we're finally merging those two streams. There is no difference between a passkey that's stored on my system and a passkey, essentially, that's stored on my FIDO2 token.
So are we saying that they are comparable,
Yes.
equally secured?
I mean, equally secure is a strong word, right? You
Okay.
have, with a physical hardware key, of course, you have a smaller attack surface. That's always going to be the case, right? So there are certain benefits for high-risk users, and enterprises might want to go for a physical key because of the smaller attack surface, as I said, and the auditability of it. I mean, auditing a operating system like Android, I mean, that's like a huge task versus like auditing a physical security key security. But from a usability perspective, we do believe most users would not go out and buy physical keys. However, since they already have the phone, we'll kind of like meet them where they are. From a phishing resistance perspective, these two are exactly the same. From a particular compromise, like someone wants to get into your device, if they have a phone and a security key next to one another, I think the security key will hold up a little bit better because it's a purpose-built piece of hardware. But I mean, that's just speculation from my side.
Okay. Also, the last question is you mentioned the FIDO server. Is that to use to authenticate your internal environment, also to authenticate the customers?
Both.
Okay.
Yeah.
Great.
It'll be for
Thank
both.
you.
Exactly. No worries. Thank you. Oh, Jude, we got a whole
Yeah,
bunch.
okay,
Yeah.
okay.
Hi.
The question is, if I have a Android phone and a Windows laptop, both use passkeys, I have two passkeys, right?
Correct.
All right.
Correct.
So, that's difficult to wrap my brain around. If you have two passkeys, is that going to be a problem? So if I have lots of devices, I have potentially many passkeys floating around, and how secure are those passkeys? Once a device goes end of life, somebody can pull it out and.
That's a fantastic question. I think that's part of the rough edges. It's like, yes, users will have many of these. I equate it, and maybe other users don't because I haven't lived in this world for such a long time, but like I've lived in this world with physical security keys. So you can have more than one security key set up on a site to log you in. And I always had to keep track of like, where is all my physical security keys? If I have 5 keys added to the site, I need to make sure I know where all 5 of those keys are. Passkeys are not very dissimilar from that mechanism. There's different that I need to go and manage. This might become tricky for users. I'm hoping in a real user scenario, there hopefully won't be thousands. Like, you'll have one in iCloud, that covers all of your Apple devices. You'll have one in Android, that covers all of your Android devices. And you might have one or more on Windows, because Windows is kind of like separate right now. So most users, maybe 3 or 4 for a given website. Over time, I am hoping that passkeys will go the way that password managers went, and hopefully users can start using a single management scheme that only has one passkey and then encompasses all of the devices that they're on. There are still reasons why that is not possible today, but I think even with that, it should be something that we can do.
Okay, so who owns the FIDO server? Is the Google or one of the identity providers, or who owns the FIDO
Pretty much
servers?
all of the above. It's an open source piece of software, so anyone can build their own, anyone can download one from the internet, or you can buy one commercially.
Thank you.
Cool. Oh, hi.
Hey, I got a question. You mentioned, Chrome, iOS, Android, Windows, Mac OS. What about Linux?
A great question. Linux is so hard because Linux and Bluetooth is just 2 things that don't really work very well. And also a secure key storage, like you have Windows Hello, for example, on Microsoft. There is no such mechanism on Linux, and I think mainly because no one needed it so far. Yeah. I'm seeing promising things happening. There are some Linux distributions which have support for the Bluetooth hybrid protocol, the one where you scan the QR code and can use stuff. I don't know of any Linux implementations yet that can do a platform-based authenticator with like a biometric sensor, but I'm hearing rumors and seeing that folks are interested in starting to come up with potential solutions there. So I want to say Linux is perhaps like a not yet completely, but I'm hopeful that over the next year or so, we'll start seeing open source implementations appear there.
Okay, thank you.
Cool, no problem. Thanks.
I had a question. Passkeys seem like something which is federating the auth to whoever is managing my passkeys now. So what are your thoughts on, like, if I'm doing with Google, I need to now, like, I assume I have passkeys with Google. I have lost all my devices. I buy a new device today. How do I log into my Google account?
Yeah, that's a fantastic question, and you're right. If you squint, managed passkeys start to look a lot like Federation, right? Not in the three-legged way where we have like, IDP and others involved. It's still a two-party system, right? It's still the passkey, my device to you, but there is another leg which gets the passkeys from Google to my device. Now, one thing is, if your device gets invalidated, let's say like Google cancels your account or whatever, it's still your passkey. It's remain on your device, right? So things continue to work, unlike with Federation. We also have, this issue right now where, on Android at least, the passkey can't be your way back into your account, because what if you lose everything? You don't have a passkey, how are you going to come back in? So we're doing a lot of work separately to try and figure out what the solution to that problem is going to be. Some kind of a backstop, right? Something that allows you to prove your identity to Google so you can get all your passkeys back. That is why we're not getting rid of passwords overnight. Your password will still remain an option to get into your Google account, perhaps with some other MFA options, because in the event that you lose everything, that'll still be the thing that you'd need to do. However, because fewer and fewer users willing to use those mechanisms, we can start to subject that to more friction. We might very well tell you it's fine to log in with a password and an SMS, but you're going to wait 24 hours before you get access to your account back, while we make sure there is no other real owner of the account like trying to get back in. So lots of things that we can do to kind of like increase that friction here, but you're right, that is still an unsolved problem, and we need to think about that carefully.
Got it. One more question.
Sure.
When you're registering a key, at that point, are you considering malware on the device as a threat? No.
We are not. We are not. Malware in the device is out of scope for our threat model here.
Any reason why?
Because it's hard. It's too hard. It's too many problems to solve. Okay. If malware is in the machine, it already invalidates a lot of other security assumptions, so it wouldn't be fair to put that in scope for this particular one here.
Got it. Thank you so much. Thank you.
Okay, no worries. Sorry. Last one, and then we should probably rock, right? Yeah.
So on the Federation topic, I'm assuming that this is compatible with something like SAML and SSO in an enterprise. Once you get your identity provider and you make your authentication, any Federation is completely compatible.
Absolutely,
right?
100% correct. The two are completely separable, yes.
Okay, so the Federation happens, the authentication happens between you and your IDP, the FIDO server's there. Other services take that SAML assertion and can still work.
100% correct, yeah. Thank you. All right, thank you, folks. I'm sorry. We probably need to break here. Thank you all.